Hello again. Hope you guys are having a good week. We're halfway through November, guys. We are almost to the end of the first semester. So today we are going to kind of pick up where we left off with naming compounds and molecules. So today we're going to be talking about covalent molecules. So just kind of a refresher here, the difference between covalent and ionic. Covalent molecules are going to be between two nonmetals. Okay, so that's everything in this top right corner of your periodic table. Ionic bonds will be between a metal and a nonmetal. So if you're checking the electronegativity on them, it's going to be anything with an electronegativity difference greater than 1.8 is ionic. If it's less than that, it will be covalent. So when you guys are writing formulas and writing the names, or you're practicing your nomenclature, it's really important to differentiate whether it's an ionic bond first or a covalent bond, because the rules are different. So that is the trickiest part of all of this, is remembering to differentiate between ionic and covalent, and then remembering their individual sets of rules. So when we're naming covalent compounds, you're going to be using your prefixes. Okay, so you will always have two prefixes unless the first element only has one atom. So if your first element is only comprised of one atom, you will not put mono on that. But that's the only time you're not going to use a prefix. So you need to memorize these 10 prefixes. So for one, it's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So with these, let's see here. Do I have? Yeah, and those came up in kind of a strange order. Sorry about that. So the rules for naming your covalent compounds: you are first going to figure out the number of atoms for your first element and add the prefix to that name, only if it's more than one. And then for the second element, you're going to figure out how many atoms there are and then add your prefix and change the ending to IDE. So that is the same as ionic, is changing that ending to IDE. So for this example, you have SiF4. Your first element is silicon. So no subscript indicates that there's only one atom. So we know that there's just one atom for that. So you're not going to put a prefix on it. The second element has 4, so that little subscript of 4 indicates that there's 4 atoms of fluorine. So the correct way to write this would be silicon, and then tetra for 4, fluoride, changing that fluorine into fluoride, okay? So changing the ending to IDE. So silicon tetrafluoride. So just some more examples of this. We would have PF3 would be phosphorus trifluoride, carbon monoxide. So notice these are both only one element, but there's only one atom of each of these, but you're not putting the mono designation on the first word. For the second one, for this third one, we'd have dinitrogen pentoxide. So sometimes the second element, the name of it can be a little bit of a stretch from what it is on the periodic table, but we still have kind of the root here of ox, which is representing oxygen. So pentoxide, and notice here this is not pentaoxide, it's just pentoxide. So if you have two vowels on top of each other, you would drop the A off of the prefix. So for this last one, we would have dihydrogen monoxide. So for writing your covalent formulas, these are your rules for that. You're going to write the symbol of the first element followed by a subscript that indicates the number of atoms, and then repeat that for the second element. These are actually really easy. So all you have to do is memorize these prefixes and you are good to go. So diphosphorus pentoxide, so di represents a 2, and then the pent represents 5. So we know that there's going to be 2 phosphorus and 5 oxygens. So this is how you'd write the formula, P2O5. And remember, they are subscripts again, just like they were with ionic. So just some more examples of this. Iodine heptafluoride. So since iodine does not have a prefix, we're assuming it's just 1. And then hepta is your prefix for the next one. So you have heptafluoride gives you 7 fluorines. Tetracarbon decasulfide. So we have carbon and sulfur. We have 4 carbons and 10 sulfurs. Notice we are not simplifying these. That's really important. So for covalent molecules, you do not simplify the subscripts. So with ionic ones, you did. So if you had an ionic compound and you had a 4 and a 10, you would have simplified that. But we are not doing that for covalent. Because covalent compounds, many of them are made of the same couple of elements, and the amount of atoms involved will change what the molecule is. So for covalent formulas, we're not simplifying that ratio. So the next one, dihydrogen monoxide, should be one you're familiar with, and then carbon monoxide, CO. Okay, and that's it for today. So next class, we'll start talking about chemical formulas. So for your assignment for today, let's get back on cis real quick. Actually, I'll just let you know. So go on cis. There is a couple of things going on today. So I want you guys to participate in the Quizlet or the quizzes, whichever, I can't remember which one it is right now, but there's one of those is assigned. I think it's a quizzes for practice. And then obviously you've just done the notes, and then you do have a practice assignment that is giving you both ionic and covalent compounds. Okay, so you're going to have to first differentiate whether it's ionic or covalent and then apply the rules separately. So again, if you have any questions at all, please let me know, and I hope you guys have a good rest of your week.